Hello, my name is Peter Raymer. Today we're going to be talking about outer joins, exists joins, and non-exist joins in Microsoft Dynamics 365 for finance and operations. So in the previous article and video, I told you about joins and really explained what joins are, how joins allow you to combine data from two different tables together, but the way that data is combined changes depending on what type of join you're using. We also looked at the differences between using T-SQL joins and X++ joins and really went into depth on how you can understand how joins work. So I recommend you watch that video first and then come to this video for a few of those more complex and different types of joins. So let's go ahead and jump right in. Here I've got a project and a runnable class/job, and I've created a method for outer join example in my main static class here, or static method. And then here's my code. So you could just copy this code directly into your job and that would work as well. So let's talk about a functional example where you would want to use an outer join. So consider you've got in D365 a lot of items, and items can be set up in a few different ways. They can be set up with no product dimension combination, or they can be set up with some product dimension groups such as size and color. So one with a product dimension group would be something like a t-shirt. You might order a t-shirt in multiple colors like black and green and orange. And then you might have multiple size options as well, small, medium, or large. Maybe you've used a website where you had to select a particular item and then which options, or often called variants, within that particular item and item ID that you're selecting. Other items wouldn't have variants. Maybe you're buying a set of speakers and there's no other options, and that would just be a regular product. Many clients and systems will set up just all their products with no variants. Some like to use variants as well. When you use variants within D365, you use this table here called invent dim combination. And so any product with those variant options should have this invent dim combination record for each combination. So maybe a small black t-shirt or a medium orange t-shirt would all show up as options in this invent dim combination. And all products, regardless of whether they have those variants or not, would show up in this invent table. So let's pretend that we want to loop through all of the products in the system and display, if they have a variant, what variant ID that is, or invent dim ID in this case, or if they don't, we don't display that invent dim ID. We can do that using an outer join. So if I bring up my little diagram, my Venn diagram of what an outer join is it's similar to a join. A join is just this middle section only where a match has to exist in both tables. Whereas an outer join, it really is the same thing as a left join or a left outer join in T-SQL. In T-SQL, there's things such as a right outer join, which would be this opposite circle here, and then there's a full outer join, which is everything. It's important to understand that an outer join in X++ really is a left join or left outer join in T-SQL. So it's going to return all records from our first table, and then if there's a match in the second table, it will load that data into the table buffer, in our case invent dim combination table. If there's not a match, then it won't. It just will leave that table buffer blank, but it will still include the record from the first table. It won't filter it out like it would with a join. Similarly to like a join, if there are more matches in the second table, it will multiply and increase the result set. So if I have 50 items in this first table and all of them have 10 records in the second table, we're going to end up with 500 results in the end. And so that's really important to understand that outer joins can still increase the number of records in the result. So let's look at some X++ code here. So we're while selecting through invent table, which is our first or left table. I'm filtering on 3 specific items, so we get a mixture of ones with these combinations and ones without, and I didn't want to print out every item in the system. And then I'm outer joining to invent dim combination on the criteria item ID. I'm then going to print out the item ID, the item name, and if there exists an invent dim combination record, the invent dim ID. Now note, if there's not, if we do not have a record that matches in the system, the first 2 fields will still show. We'll still load the invent table, but this one will be blank. So it won't be null like in SQL, but it will be an empty string or a 0, and so we'll just get an empty string displayed. So let's take a look at that. If I bring up the browser where I've run this job, I can actually scroll through and see, yeah, I've got a whole bunch of 0141, which is a girl's t-shirt that has different combinations of invent dim ID. So I can scroll through, see all those different invent dim IDs, and if I eventually scroll far enough, I'm going to actually find a couple products that don't have my dimensions right here. The 0179 men's low cut athletic socks, I believe, and it's going to display an empty string here instead of an actual value because that invent dim combination record was not loaded. Same thing with this item here. So that's really the power of outer joins. Is I like to think of it as an optional or a maybe join, where we're going to join that record if it exists, but if it doesn't exist, that's okay. We're still going to loop through all the records in our main table, and that's really effective for scenarios like this. I'm going to show you what this looks like in SQL Server Management Studio, as this is a great tool to be able to see and understand what this means. So if you open SQL Server Management Studio on a cloud-hosted development box and click OK on the dialog box that opens up, you can then change this dropdown to be AXDB, which is the name of the database where Dynamics 365 data is stored. Then you can click the New Query button. It's going to open a new code editor window. And then you can paste in this code that I've have in the article. And then finally you can click the execute button, and it's going to return the result set. So this is the same query, but in T-SQL. We're doing left join to invent dim combination table. I could do left outer join. It's the same thing, but most people find it easier to leave out that word outer and just call it left join. And then in the case of T-SQL, I do need to relate on data area ID and a where clause on data area ID for the specific D365 company or legal entity that I'm in. I don't need to do that within X++ because the system does that for me under the covers. It's implied by what legal entity I'm logged in as. So here I like this because I can really easily see the data that's being returned. I can see the item ID, the name, the invent dim ID, and I can see those change. I can see my girls' t-shirts, and then if I scroll further down, I can actually see my items that don't have a variant. My reflective ankle band, or my men's cushion socks, or black striped scarf. All of these, when they don't have a related record in this table, they're going to return null. And null is a representation of lack of data. So it's not actually storing the characters NULL. It's showing us that there is no record, and therefore it can't return any data for these columns. But the important thing to note is it's still returning every record that matches in this indent table. So that's really useful. I think of outer join as kind of an optional join. I'm optionally joining in this second table if it exists. If it doesn't exist, I won't get data back. So I need to be aware of it, but that's okay. Okay, we've really looked at outer joins. I guess the last thing that I'd say about outer joins is the order of table matters. So if I switch the order and put invent dim combination first and invent table second, that does change how it works. So I could look back at SQL. I can look at this example here where I've done just that. And when I do that, I'm only going to get records back that have combinations because I've got that table first. I've got my boys t-shirt and my girls t-shirt in this case, but I'm not going to get my other items. So it's really important to understand that with outer joins, the order of your tables matters, whereas in joins, that may not be true. Okay, so the next one we can look at is exist joins. If I bring up my little diagram for exist joins are very similar to regular joins in that the returned records have to exist in both the first table and the second table for us to get a result. But what's different than a regular join is that I will only ever get the same number of records that exist in a first table and a second table. In a regular join, if there's a one-to-many relationship, like I'm joining sales orders to sales lines, I'm going to get one record back in my result set for every single sales line that's on a particular sales order. Whereas with an exist join, I'm really just checking to see, is there a record on the second table? If there is, okay, I'll use that as a criteria to be okay to return my first record. So I can take sales orders, exist join to sales line means return only sales orders that have one or more sales line. But if they have 100 sales lines, I don't want to see 100 records back. I won't get 100 records back like I would with a join. I'll only get one record per sales line. And that's really useful. There's no such thing as a exist join in T-SQL. So that's the other thing I'd say. It's just a concept in X++. There is something called the keyword exists that you can use in a similar fashion, but it's really used as part of the where clause within T-SQL, whereas in X++ we can actually use it in a join statement. So let's look at a couple examples. Here I'm just doing a regular join. I'm not doing an exist join. So in this code, it's going to return a record for every sales line on excuse me, this sales ID. So I think there's 4 sales lines, and so I'm going to get 4 records back if I print this out. But if I do a while select sales table on a specific sales ID and I say exist join sales line, I'm really just checking to see, hey, does there exist one or more sales line? If there does, go ahead and include this sales table in the results. So I'm actually only going to get one record back when I print this out. And if I know I'm only going to get one record back in a certain case, I could even change it to be a select first only statement. You got to be a little careful with that. It really depends on what unique indexes you're using, but that's important to know as well. So you can use exist joins to essentially return back just one record. So there's a few key things that are really important to know about exist joins. One is that exist joins don't actually return any data for the table that we're joining. They're really just checking to see if it exists and using it to filter on whether we return this first record or not. So what that means is in my info statement here, I'm actually trying to print out a sales line.item ID, and this statement won't work. We're not actually returning and reading any of the columns from sales line when we do an exist join. And so it's going to print out just an empty string in this case. This table buffer for a sales line is going to be completely empty. So if you need to read data or use data out of this second table, don't use an exist join. You're going to want to use a regular join. However, if you don't need to return any data and you understand that you're only going to be checking for one record and moving on, an exist join is a great way to increase performance. If you're querying on a primary key, where you know that your join criteria, your work clause is only ever going to join at a one-to-one relationship, switching a join to an exist join is going to increase the performance of your query. You just need to be really careful and sure that you've got a one-to-one relationship when you're doing that, or that you intend to only return and check if there's one record. The other key thing that's really important to know when using an exist join is you need to use your exist joins last in the order of joins. So if you're joining 10 different tables together, you need to make sure your exist joins are always at the bottom, because once you use an exist join, basically every join afterwards is going to be treated like an exist join, and so you may not get the results that you're looking for. So make sure all your exist joins are at the bottom, reorder your where clauses so that they can be at the bottom, and then test, make sure that it's working the way you would expect. Again, exist joins are really fantastic for improving performance. You just need to be definitely very careful with them. Okay. Last one is non-exist join. So let's look at that example in X++. Non-exist joins are essentially the opposite of exist joins, where they're going to check to see if there doesn't exist a record based on the criteria you specified, and only in the case where there's not a record will it return a result from your first. So in this example, I'm looping through all the sales orders that have a back order status or open order status, and I'm looking for sales orders that don't have any sales lines entered against them. If they don't have any sales lines entered, maybe they were created by mistake. They're okay probably for me to delete them. Maybe that's what I'm looking for. And so using a non-exist join is a great way to look for records where there's a record in one table but not in a related record. So I can bring up my little diagram here. And so this is what a non-exist join looks for, is I'm going to look for where there's a record in the first table, but there doesn't exist a match in the second table. This is really useful for different, maybe periodic batch jobs where you need to have a related record created, or you want a batch job to create that second record. You can run that batch job on a reoccurrence, say once a day, and maybe users are responsible for entering data into that first table, but you need to have that batch job create that second related record. Well, you can use a non-exist join to look for where that second record's missing and then maybe insert it. So using it with an insert record set, which is something we haven't covered, can be a great way to use a non-exist join. Again, it won't select any data in here because there's no record that exists, so please keep that in mind. So again, when I'm trying to display this sales line item ID right here, that doesn't actually work. So we just are going to return the sales orders and not return anything from this sales line item ID. So that's just really important to keep in mind. Okay, so we've really, through these couple videos, looked at all the different types of joins within Dynamics 365 for finance and operations. We've looked at the differences between T-SQL and X++. These are definitely complex topics, so I recommend you play around with them both in X++ as well as in SQL Server Management Studio. I usually write really complex joins in SQL Server Management Studio first because I can so quickly test and view the data, make sure that it looks correct, and then I can translate that data back into X++ select statements or while select statements once I feel like I have it right, and kind of test again and make sure that I've got the syntax correctly. Again, this takes a lot of time to kind of master, but it's a key concept. There's some other pieces to these while select and select statements that I can show you in some later videos. But thank you so much for watching. I really appreciate you watching. If you liked the video, click the like button. I also invite you to push the subscribe button as well. If there's other topics you would like to see a video on, please post in the comments and I'll see what I can do. I hope you learned something new today. Thank you.